everybody, it's Miss Smith. So today we're going to talk about simple machines and types of heat transfer. Now we're just kind of getting some random terms here and there. We will be using them more in depth a little bit later, but I've got to teach you the basics before we get anything any more difficult. So I guess they're kind of random right now. Anyway, so today before we go into the notes, I want to talk about what work is. Now, when you think of work, you probably think about your job or sitting and doing work for my class or somebody else's class or something like that. But in scientific terms, that's not what work means. In scientific terms, work is a force applied to an object, and then that object has to move a distance. So you have to have two things that happens to the object in order for work to be done, and both of those have to be met. So the first one is a force has to be applied, and then that object has to move. So if I was to take this pen and I'm just holding this pen still, I'm applying a force because I'm holding it up, but I'm not moving it, so that's not work. But if I move it, then technically I'm doing work because I'm applying a force and it's moving. All right, so let's go into our notes for today. All right, so the first thing that I want to talk about is simple machines. There are 6 of them. Yes, you need to know all 6 of them. You have a quiz on simple machines on Monday. You will not be quizzed over simple machines today because I want you to study for it over the weekend, and then on Monday I'll quiz you over that. So for the quiz today is only 4 types of heat transfer. So first off, let's talk about what is a simple machine. It is a device that makes work easier. Normally, a simple machine will do this work in one motion. Okay, but anyway, let's talk about the 6 types. So the first type that I want to talk about is a pulley. Now at this point, you should be filling out like a little notes chart. All of this needs to go in here. You will use this information again. Okay, so a pulley. So the definition for a pulley is a grooved wheel. I'm going to zoom in a little bit. A grooved wheel with a rope running along the groove. Okay, some examples. A pulley itself, a block and tackle. If you don't know what that is, it's just a bunch of pulleys together all in one. A come along. This is what you use to put in barbed wire fences. Rigging on a flagpole. A fishing reel, not the fishing pole, but the reel with the line. So that technically the fishing line would count as that rope. All right, the next one is a wedge. A wedge is an inclined plane with 1 or 2 sloping sides. Examples are a knife. Technically it has 1 sloping side. Scissors, they have sloping sides. A maul, M-A-H-L. That is similar to an axe. You do use a maul to split wood. But the maul itself is a little bit different than an axe, but you're still going to use it to split wood. But also an axe fits into this category, and like a doorstop fits into that category as well. All right, the next type is an inclined plane. Okay, definition for this one. A sloping surface that reduces the amount of force required to do work. So this is going to be any kind of ramp or wheelchair ramp. Another example would be a loading dock or the ramp on a U-Haul truck. All right, the next one is, there are 6 of these, so we've got 3 left, is a screw. So a screw is an inclined plane wrapped in a spiral around a cylinder. Okay, the example is a jar lid threads, a screw, of course, a bolt. For those of you that know what all thread is, it's like a super, super long bolt, but there's no end on it. Light bulb threads. Those are all examples. Okay, next one is a lever. A lever is defined as a bar that pivots around a fixed point. That pivot point is called a fulcrum. Examples: a seesaw that has the fulcrum in the middle, a crowbar. Technically, the fulcrum of a crowbar is in your hand, because that's where it pivots. It's also, let's see what else, a baseball bat. It's also in your hand. A door, the hinges are the pivot point. A fishing pole, not the reel, but the pole itself. The pivot point technically is your hand. Okay, last one is a wheel and axle. This is probably the one that everybody's like, I don't agree with these examples, but let me explain. Okay, so let's look at the definition for this one. It's a shaft or an axle attached to the center of a larger wheel. So, for example, a pencil sharpener. Okay, so you're like, well, wait a minute, Ms. Smith, where's the wheel on a pencil sharpener? Technically, the handle, so I'm talking about the grinding pencil sharpeners, like the old school ones that are attached to the wall. Technically, the handle, that you go around in a circle, technically that's the wheel. And then the shaft is the grinding part on the inside. Okay, another example would be a doorknob. Technically, the wheel is you turning your hand, the part of the doorknob that you actually turn with your hand. And then what's inside the door that turns is the axle. Faucet handles, again, the handle itself is the wheel and it's attached to a shaft. Another one would be a screwdriver. Okay, even though the wheel on a screwdriver is really, really small, you're still going to rotate it. You still got something rotating around a shaft. So it's a screwdriver. Okay, so those are all the examples of these 6 simple machines. Now on your quiz next week, what I will do is I will present to you a simple machine and you have to identify which simple machine it is. All right, so let's move on to types of heat transfer. Okay, so the first type we're going to talk about is conduction. So this is the second page of the notes document that you're supposed to be looking at. Let me make this a little smaller. So the definition for conduction is heat transfer through direct contact. So this would be like cooking, I don't know, let's say that you're cooking a grilled cheese. I'm going to say cooking in a pan. So that hot pan is touching directly that grilled cheese. So that would be direct contact of heat. Now, the other thing would be heating up a pan. Now, a lot of the time, like if you're using a gas stove, the flames may not actually touch the pan. So that would not necessarily be conduction. They actually have to touch the pan. So that's the reason why I put electric stove out in parentheses. Okay, the next one is convection. That is heat transfer through a fluid. And then a fluid, I need to define this. A fluid technically is any liquid or gas. Okay, so any of those, liquid or a gas, counts as a fluid. So a convection oven, now a convection oven is different than a regular oven because a regular oven just works off of radiation technically because it has a heat source that it's radiating heat out of. But a convection oven has a fan that circulates the heat and it actually cooks your food more evenly. So that's a convection oven. Hot inside of a car. Sitting in the sun. Okay, that happens through the air that's in the car. The sun heats up the air in the car. Even though the heat coming from the sun is technically radiation, I mean, if you were talking about heating up the outside of the car, well, we'll talk about in a minute, that's technically the third type, which is radiation. But I'm talking about what's happening on the inside of the car. That is because of the hot air in there and it's circulating. Okay, the last type is called radiation. Now, this is not like radiation we're talking about, like uranium and atomic bombs. That's not what I'm talking about. When I think of radiation, I think of the word radiate. That's the word that I think of. So it radiates heat. This is also, it's done through electromagnetic radiation. So light and radio waves and microwaves and X-rays and all of those things on the electromagnetic spectrum. But it'll radiate heat. It'll come from a source. So this is the sun example, the sun heating up the car. Okay, sitting out in the sun outside of the car. Another great example would be a space heater. Or getting warm by the fire. Like in a fireplace. Okay, any of those. Okay. So that's it for your notes today. On the third page of your notes document, please make sure that you do those examples. Okay, if you need some help, if you're stuck, let me know. I can help you. Okay, have a great day.